In statistics, there also are two more terms that are precisely to be understood. Those are skewness and kurtosis. Kurtosis or kurtosis, whatever way you pronounce. These are the statistical measures that will explain you the shape of a data distribution. What exactly is the skewness and kurtosis? Let us directly jump into the details. First of all, what is the skewness? The skewness measures asymmetry of the data distribution. How asymmetrically the data is being distributed. When you collect some data set, it tells us whether the data is skewed to the left or the right of the mean. There actually is a mean. For every data set, there is a mean. Where exactly this is being skewed? Is it towards the left direction or towards the right direction? We will get to know by the skewness. There may be positive skew or a negative skew or a of course, there will be the skewness will be falling under both positive skew and a negative skews. What exactly is this positive skew and a negative skew? Let us understand. Let us see what is the positive skew. The positive skew, which is also called as the right side skew, the right tail is longer or flatter than the left. For an example, let us take this. This is the mean. Okay. Here we do have the data points. Here we do have some other data points. These are the left side data points. These are the right side data points. Here, when you say positive skew, this is the right skew. The right side data points actually are limited but contributing more to the mean. For an example, there is something called income. Income is mostly falling around 50,000. Okay. Income is most of the people will get less than or equal to 50,000 rupees. But a few people would get much more than 50,000. These few people would pull the mean up. What is the average income in India? In the India, average income is around 2 lakhs. But nobody is getting 2 lakhs. Most of the average common people, below poverty people or the middle class people just are getting in and around just 30,000 to 40,000. Mean is not even equal to 50% when you consider only middle class and upper middle class people. But the thing is, the actual mean average salary is much more than 40,000 or 50,000, it is around 2 lakhs. Why? Because a few upper segmented people who actually gain their profits in crores per month, they will pull this moon up. They will pull this mean up. So here, the mean actually is skewed towards the right. Only a few data points at the right, but those data points actually are contributing more towards the mean. The mean actually is being affected by a few data points which actually are spread on the right. But on the left side, there are more data points. Those are contributing a little to the mean. I hope you got a point. Right? Example, income distribution in most countries, many people earn a modest income, but a few earn extremely high salaries. These high salaried people, they will pull this mean up. This is called right skew. The next thing is left skew. What is the left skew? In India, the biggest thing is most of the people would retire at 65 age. Okay, again there is a data set in which we collect the average age of retirement. Most of the people would fall under 65%. But recently the government launched a plan. If you retire earlier, you will be provided with these benefits. With that, many people would want to retire just well within 65. Some people would retire at 30, some people would retire at 35. Although these people are actually towards the right side, these people actually are affecting the mean more than that of the people actually who are getting retired at the 65. Okay, so this is called left negative skew. The left tail is longer or flatter than the right. But in the positive skew, the right tail is longer or flatter than the left. And the bulk of the data points are actually on the left side of the mean. Bulk of the data points are actually on the left side, but only a few data points towards the right makes it the right skewed. But within the negative skew, bulk of the data points are actually onto the left. A few data points bulk of the data points are actually on the right bigger part. But a few data points on the left actually are contributing more to the mean, which is called negative skew. The bulk of the data points are to the right on the right side of the mean. Example, age of the retirement. This is what I discussed about. The retirement age is 65, but a few might retire earlier, which contributes more to the mean. Okay, what are the skewness values? Zero skewness, positive skewness, and negative skewness. Zero skewness is symmetrical distribution. Positive skewness is distribution is right skewed. Negative skewness is distribution is left skewed. These are the terminologies that we need to remember. Zero skewness, symmetrical distribution. It's a normal distribution. Nothing is skewed up. Data is evenly poised. Okay, across axis. The positive skewness, it is positive skewed. The data points which are at the positive side towards the right side actually are contributing more. Negative skewness, data points towards the left side actually are contributing more than the right side. These are the terminologies that we should understand. The next thing is the kurtosis. Kurtosis is another important factor to understand. What exactly is the kurtosis? Kurtosis is the measure of tiredness or the sharpness of the peak of the distribution. Sometimes we will see huge peaks in the graph. When you collect the data points, there will be peaks and low values in the graph, the valleys in the graph. By using the kurtosis, we will be able to measure these peaks. Okay, the types of kurtosis are leptokurtic, platokurtic, and mesokurtic. What is leptokurtic? This leptokurtic states that high kurtosis. There will be huge peaks. For an example, there is a stock market. Stock market is the best example for the leptokurtic. Suddenly there will be highs, at the same time there will be lows. The peaks will have the sharp curves, sharp edges. Okay, that is what. The distribution has a tall sharp peak and a heavy tails. The moment it falls down, it will have a huge tail. And there are more extreme values in the data set compared to the normal distribution. As compared to the normal distribution, there will be extreme values. Stock market will always fluctuate in between high point and low point. It never goes in a uniform distributed manner. Okay, that is what? Leptokurtic. Stock market return where large fluctuations are actually expected. Platokurtic. The distribution has a flat peak and a light tails. Peak is flat and the tails are very light indeed. Okay, the best example for this is heights. In India, average height is around 5.6 or 5.7. But a few people will have more height, right? The height of a few people is more than the other people, like 6 or 6.2. But the instances are very minimal. The people who actually has those heights are very minimal in number indeed. So that comes under platokurtic, which is called low-kurtic. Data is more evenly spread out with a fewer extreme values. Okay, mesokurtic, normal kurtosis, a normal distribution where the kurtosis is equal to 3 is called mesokurtic. It has a moderate peaks and tails. For example, heights of the people in a large population typically following a normal distribution. In a large population, some people are of more heights. At that time, generally the graph is very flat, but at some point there will be some peaks. Okay, so in Africa, you do see these kind of people. In some tribal colonies, generally most of the people are poised across 5.2, but some people will be of 6 to 6.2. There are some tribes in which the normal heights are around 5.2 to 5.3. But in the same tribe, some of the people will be of 6 feet tall. Those will fall under mesokurtic. The mesokurtic value is equal to 3. Actually, it is measured by 3. Okay. Now, kurtosis values will actually is measured around 3. In the normal distribution, kurtosis is called as a 3. It's called a mesokurtic. Mesokurtic value is equal to 3. It is a moderate peak and tails. Let us understand the kurtosis values. Kurtosis value, if it is equal to 3, it is a normal distribution. If it is greater than 3, it is leptokurtic, high kurtosis, like our stock market prices. If it is less than 3, it is platokurtic, low kurtosis, the fewer outliers. This is what the kurtosis. In some statistical software, of course, it is in only some softwares there also is an additional measure of this kurtosis. What is that? There is something called excess kurtosis. What is an excess kurtosis? Where 3 is subtracted from the kurtosis value. Okay, excess kurtosis is 0. Normal distribution. Actually, what is normal distribution? In the normal distribution, kurtosis value is equal to 3. 3 minus 3 is equal to 0. Okay, excess kurtosis 0 is equal to normal distribution. Excess kurtosis greater than 0 is leptokurtic. Leptokurtic. Meaning, what is leptocotic is generally more than 3. More than 3 minus 3 is equal to, it is greater than 0. That becomes leptocotic. What is excess kurtosis is less than 0? It is called platocotic. I hope you got the point. This is what the kurtosis is all about. Thank you so much.